Good day, everyone. We are the reporter of the nature of mathematical system, and I'm Angeline R. Magtubo, the first reporter of our group. I'm here to report or discuss the meaning of a relation and the four representation of relation. So when we say relation, it is a set of ordered pairs. So the example of relation is -2 and 2, 2 and -2, 0 and 1, and 3 and 4. So the set of all first coordinates is the domain, which is, we know that the x of the relation, while the set of all second coordinates in the range is y in the relation. So, the ordered pairs in a relation ay merong domain and range. So, our x value is our domain and the y value naman is our range. When we say relation, it is an ordered pair, meaning any ordered or any number pairs are masasabi nating relation. So, sa example natin, sa taas, our domain or x value ay yung mga nasa unahan, which is yung -2, 2, 0, and 3. While yung range naman natin or yung sinasabi nating y value is yung mga nasa pangalawang bahagi, which is yung 2, -2, 1, and 4. Kapag sinabi nating domain, ito yung tinatawag nating input. While pag sinabi naman nating range, ito yung tinatawag nating output na ordered pairs or ordered pairs sa relation. So, let's proceed naman sa representation of relation. So, sabi dito, a mathematical relation is the pairing up mapping of inputs and outputs. It can be represented in 4 different ways: in unordered pairs, a table, a graph, or a mapping diagram. So, aside from ordered pair, meron pang tatlong ways to represent the relation. So, this example is the example of ordered pairs. Usually, yung ordered pairs, ito yung pinaka common na ginagamit when we represent the relation. So, meron pa tayong 3 ways to represent a relation. So, yung second one naman is yung table of value. The third one is the mapping diagram, and lastly, yung graph. So, etong example natin in ordered pairs ay itatry natin to represent using table of values, mapping diagram, and graph. So, unahin muna natin yung table of value. When we say table of value, gagawa tayo ng table. Pwedeng horizontal and pwede ring vertical. But here's sa example, let's make a representation using vertical table. So, since sa relation, we have a domain and range, so yung table natin ay nahahati lang sa dalawa, which is the x and y. So, if tatanungin nyo if yung sa ordered pairs natin, if pwede ba nating ilagay sa table of value, the answer is yes. All we need to do is lahat ng x or lahat ng nasa unahan ay ilalagay mo sa table ng x, while lahat ng nasa pangalawa na mga number ay ilalagay mo sa table ng y. Kapag nilagay mo na lahat, meron ka ng table of values. Katulad ng nasa example, yung -2, 2, 0, and 3 ay nasa table ng x, while yung 2, -2, 1, and 4 nasa table naman ng y. So, parang isasalansan mo lang yung ordered pairs na ginawa mo dun sa table na ginawa mo. So, proceed naman tayo sa mapping diagram. When we say mapping diagram naman, ito yung gagamit na tayo ng arrow. We use sa arrow para ma-point natin yung kanyang correspondent. So, for example, si X, ano yung correspondent elements niya sa Y. So, here's sa mapping diagram, usually ang ginagamit natin dito ay bilog or oval. it is yung way para ma-represent yung two elements, which is yung x and y. So, etong mapping diagram is same procedure lang din sa table of values. Lahat ng x natin ay ilalagay natin sa x na bilog, and same sa y. Lahat ng y natin ay ilalagay natin sa bilog na nagre-represent ng y. So, ito yung outcome. So, makikita nyo dito sa example natin, yung sa mapping diagram, yung under ng x natin is -2, nilagyan natin siya ng arrow para ma-point yung correspondence niya sa y, which is yung 2. So, another example naman dito sa next slide. Another example of mapping diagram. So, meron tayong 2 and 3, 2 and 4, and 6 and 5. Siguro may magtatanong sa inyo kung bakit tatlo naman yung value ng x, pero pagdating sa mapping diagram natin is dalawa na lang. Take note guys, na kapag naulit na yung value sa x, no need nang ulitin sa mapping diagram. Kasi katulad ng sinabi ko kanina, ang importante naman sa mapping yung arrow. So kahit isa lang yung ire-represent na sa x value, may iba yan sa correspondent ng y. Katulad ng example natin. Always remember din na there's always a correspondence range in every domain. Meaning dito, may mga always na may correspondence ang y natin sa lahat ng x. So, sa ordered pairs kasi natin, 'di ba, meron tayong 2 and 3 and 2 and 4. So, kapag minapping diagram na natin siya, under ng x is isang 2 na lang, kasi pwede naman siyang dalawang arrow para mapakita yung correspondence na nasa y, which is yung 3 and 4. So, let's proceed naman sa last one na pwedeng mag-represent ng relation. So, yung last one naman is yung graph. We can also give a representation relation using graph. So, paano ba mag-graph? So, here sa example, graph natin is makikita nyo may mga potted point tayo dito. So, paano ba natin i-represent ang ating relation using graph? So, ang gagawin lang is ipa-plot mo lang yung ordered pairs. So, for example, sabihin natin walang ordered pair since it is also one of representation of relation. An example, binigyan lang tayo ng prof natin ng graph. Always remember na kahit graph lang yung binigay sa inyo, this is also a relation, or makakagawa ka pa rin ng ordered pair using a graph. I know very familiar kayo dito sa graph, and alam ko lahat tayo nakagawa na ng graph. So, dito sa graph natin is nahati sa x and y yung graph natin. So, sa graph natin, nahati ito sa x and y, and nahati din to sa positive and negative. So, kapag may ordered pairs na tayo, pwede natin silang ilagay or magkaroon ng plotted point para masalansan yung ordered pairs natin into a graph. So, again, if magre-represent tayo ng relation, it can be represented using ordered pairs, table, mapping diagram, and graph.
Reflexive relation. A relation R is reflexive if every element in the set is related to itself. Example number 1. Set A is composed of 1, 2, 3, 4, 5, while set R is composed of 1 and 1, 2 and 2, 3 and 3, 4 and 4, 5 and 5. Now, this example is a reflexive relation because every element in set A is also an element in set R, and every element in set R is also an element in set A. Let's go with example number 2. Set A is composed of A, B, C, E, F, while set R is composed of A and A, B and B, C and C, D and D, E and E, F and F. This example is not a reflexive relation because the element D and D in set R is not an element in set A. Symmetric relation. A relation R is symmetric if A and B is an element of R implies that B and A is also an element of R. That is, if A is related to B and B is related to A. Example number 1. Set A is composed of 1, 3, 5, 7, and 9, while set R is composed of 1 and 3, 3 and 1, 1 and 5, 5 and 9, and 9 and 7. This example is symmetric relation because every set in set R is related to the set before them. 1 and 3 is related to 3 and 1, 3 and 1 is related to 1 and 5, 1 and 5 is related to 5 and 9, 5 and 9 is related to 9 and 7. Now let's go with example number 2. Set A is composed of 2, 4, 6, and 8, while set R is composed of 2 and 6, 2 and 4, 4 and 8, and 6 and 2. This example is not symmetric relation because not every set in set R is related to the set before them. 2 and 6 is related to 2 and 4, 2 and 4 is related to 4 and 8, but 4 and 8 is not related to 6 and 2.
Antisymmetric relation is one type of relation that can be defined when a set has no ordered pairs having the similar element. All the ordered pair must have the same element. A relation R of a set A is antisymmetric if A and B element of R and B and A is element of R, then A is equal to B. In a simplest explanation, a relation is antisymmetric if no two distinct elements are symmetrically related. Example number 1. In a set E is equal to 1, 2, 3, let R be a relation in E such that R is equal to 1, 1, 1, 2, 1, 3, 2, 3, and 3, 2. The R is not antisymmetric since 2 and 3 and 3 and 2 is the element of R. Example number 2. Set E is equal to 1, 2, 3. Consider the following relation R in E. Determine whether each or not each of these relations is antisymmetric. Example number 1. Set R1 is equal to 2, 2. This is antisymmetric. R2 is equal to 2, 1, 2, 2. Is also antisymmetric. R3 is equal to 1, 1, 2, 3, 3, 2. This example is not antisymmetric because of the set 2, 3, and 3, 2. Transitive relations are binary relations in discrete mathematics represented on a set such that if the first element is linked to the second element and the second component is associated with the third element of the given set, then the first element must be correlated to the third element. Mathematically, we can address it as a relation R marked on a set A is transitive relation if A and B element of R and B and C element of R, then A and C element of R for all A, B, C is correlated to A. Example number 1. Set A is composed of 1, 2, 3, and 4. Set R is composed of 1 and 2, 2 and 2, 1 and 3, 2 and 3, and 2 and 4. Then R is not transitive since 1 and 2 and 2 and 4 element of R, but 1 and 4 is not the element of R. Example number 2. Set E is composed of 1, 2, 3, and 4. Consider the following relation R in E. Determine whether or not each of these relations set R in E is transitive. R1. Set R1 is equal to 1 and 1, 2 and 1, 2 and 3, 3 and 2. This set is transitive because they are correlated to each other. R2. Set R2 is composed of 2 and 2, 2 and 3, and 2 and 4. This is also transitive. Set R3 is 2 and 1, 2, 2, 2 and 3, 1 and 4. This is not transitive because the 1 and 4. R4 is composed of 1 and 1, 2 and 3, 3 and 2. This is also not transitive because of the 1 and 1.
Function. Functions are the most useful mathematical idea that can be used to model the real world. They allow us to study the relationship between different structures, and they also allow us to put an algebraic structure on a set. A function is a relation where each input has only one output. In simple words, a function is a relationship between inputs where each input is related to exactly one output. The following example is how a linear function can be set up. A certain barangay high school had 520 students enrolled in 2010 and 850 students in 2013. If the student population grows as a linear function of time, where t is the number of years after 2013, so how many students will be enrolled in the school in 2015, and find a linear function that relates the student population to the time, where T stands for the time and P stands for population. The given information can be written as ordered pairs. The year 2010 corresponds to 0, and the year 2013 corresponds to 3. There are two ordered pairs, which are 0 and 520 and 3 and 850. Since the population grows linearly with the time, we use the two ordered pairs to find the slope of the graph of P as follows. So M is equals to 850 minus 520 divided by 3 minus 0. After we subtract that, the answer is 330 divided by 3. The answer is 110. The slope M is 110, means that the students' population grows by the 110 students per year. So the high school population in 2015 will be Y is equals to 110 times 5. So the answer is 550 plus 520 equals to 1070 students. Since we know the slope M and the 2 points, we can use the point-slope form to find an equation for the population as a function of t as follows. There are 4 ways to describe a function. The first one is verbal. Word description is used in this way to the representation of a function. The second one is algebraic. This representation of a function refers to the expression using an equation or mathematical model. Third is visual. In this way of representation, the function is shown using a continuous graph or scatter plot. The last one is numerical. A function is represented using a table of values or chart. This is basically a tabular way of representing a function. Discrete and continuous function. The difference between the two is discrete function is a function where the values in the ordered pairs are separated from each other and are not connected. In the other word, discrete functions show a distinct point that remains unconnected. While in a continuous function, the points are connected with an unbroken line, and the domain allows for any value in x within a finite or infinite interval. A continuous function and its respective graph can be used to determine projectile motion and explain change between two distinct quantities.
So next is the vertical line test. The vertical line test is a graphical method of determining whether a curve in the plane represents the graph of a function by visually examining the number of intersections of the curve with vertical lines. The figure shows above the two curves in the plane. The leftmost curve fails the vertical line test due to the fact that a single vertical line drawn intersects the curve in 2 points. On the other hand, the vertical line test shows that the rightmost curve is a function on its domain. Indeed, none of the vertical line drawn intersect the curve in more than 1 point, and by observation, neither would any other vertical line. Notice that the first graph or the left graph shows that the curve touches the vertical line in 2 points, so it means it is not a function. While on the other hand, the next graph on the right side, the curve only intersects in vertical line at 1 point, so it means that it is a function. So for more example, we have example A. In this graph, it shows that it is a not function because the curved line intersects the vertical line in 2 points. While in example B, it shows that it is a function because the curved line intersects in vertical line in 2 points only. In example C, this graph it shows that it is not a function because the curved line intersects the vertical line in 2 points. While in example D, the curved line intersects the vertical line in 2 points, so it is not a function. So next we have operation and function. Functions like real numbers can be combined to form a new function. The operations are very similar to the manner in which we add, subtract, multiply, and divide. So first we have addition. Function of f plus g of x is equal to f of x plus g of x. So for example, we have f of x is equal to 3x minus 5 and g of x is equal to 4x plus 6. So after this, we're gonna substitute it. So f plus g of x is equal to 3x minus 5 plus 4x plus 6. So after the substitution, we're gonna combine the like terms, which is the 7x plus 1.
Composition of function involves combining two or more functions to create a new function. This process denoted by f composed of g of x and g composed of f of x, where f and g are function. In the composition of function, the output of one function that is inside the parenthesis becomes the input of the outside function. There are two properties of function composition. Number one is associative property. If there are three functions, f, g, and h, then they are said to be associative if and only if the composition of f, the composition of g, and h is equal to the composition of f with g and composed with h. So we have here our example number 1. Let f of x equals to x squared plus 1 and g of x equals to x minus 2. Find the following compositions of functions. Letter A, f composed of g of x. Letter B, g composed of f of x. So for our letter A, f composed of g of x, we can rewrite this function as f of g of x. So we have to substitute the variable x that is there in the outside function with the inside function by taking the individual function as a reference. So we will have x minus 2 squared plus 1. So we have to expand the x minus 2 squared, so we will have x minus 2 times x minus 2 plus 1. So this, we have to use the FOIL method. So by using the FOIL method, we will have x squared minus 2x minus 2x plus 4 plus 1. So by this, we have to combine like terms so we can get the answer. So by combining like terms, the answer that we will get is x squared minus 4x plus 5. So for our letter B, g composed of f of x can be written as g of f of x by replacing f of x equals to x squared plus 1 in g of x. The resulting expression is x squared plus 1 minus 2. So to solve for this problem, 1 minus 2 is negative 1. So our answer would be x squared minus 1. Word problems involving functions. There are a lot of real-world problems that can be modeled by functions. It is important to solve the problems. One has to construct mathematical models of the real-world situations, and here are some examples below. For our example number 1, in business, the profit is obtained when the income from sales of a product is more than the cost of producing the product. Karen bakes muffins and sells them for 120 pesos each. She has a fixed cost of 960 pesos plus 40 pesos per muffin produced and sold, assuming that all muffins produced are sold. Letter A, express Karen's income function from the sales of X muffins. The income is determined by multiplying the per unit cost of muffins times the number of muffins X produced and sold. That is, Rx equals to 120x. For letter B, express Karen's cost function for producing X muffins. The cost function is the sum of the fixed cost plus the variable cost per unit. Since Karen has a fixed cost of 960 pesos plus 40 pesos per muffin produced, her cost function is Cx equals to 960 plus 40x. For letter C, express Karen's profit function for producing and selling X muffins. Karen's profit function will be Px equals to Rx minus Cx is equals to 120x minus 960 plus 40x. So we will get Px equals to 80x minus 960. D. How many muffins does Karen have to bake and sell just to break even? A break-even in business is a term that implies that there is no profit and no loss. The amount received is just equal to the cost of producing the goods. So, for Karen to break even, she has to solve Px equals to 80x minus 960. Letting Px equals to 0, the function becomes 0 equals to 80x minus 960. Solving for x, Karen has to bake and sell 12 muffins for her to recover her cost. Letter E. If Karen has baked and sold 50 muffins one day, how much is her profit? Since the profit function is Px equals to 80x minus 960, substituting 50 muffins into this function will result to Px equals to 80 times 50 minus 960 would be 3,040. Example number 2. At the Quezon City Memorial Circle, a bicycle renting shop owner charged 25 pesos rental fee for his bicycle, plus 2 pesos for every hour of an hour the bicycle is used. Write a linear function to describe the total charge, C, in terms of R, that the customer has to pay. If a customer used the bicycle for 2 hours, how much will he have to pay? The total charge, CH, equals to 25 plus 2H. Since the customer has used the bicycle for 2 hours, his total charges will be C2 equals to 25 plus 2 times 2. 2 times 2 is 4. So it will be 25 plus 4. 25 plus 4 is equals to 29. So if the customer has used the bicycle for 2 hours, he have to pay 29 pesos.
I'm Jessica Lothinko from BSA 1C, and I will discuss the next topic, which is the review and system of linear inequalities. Let's talk about the review and system of linear inequalities. In mathematics, linear inequalities are inequalities that involve linear expressions. They are similar to linear equations, but instead of an equal sign, we use inequality symbols such as less than, greater than, less than or equal to, or greater than or equal to. A linear equality represents a region in the coordinate plane that satisfies the inequality. The solution to a linear inequality is the set of all points that make the inequality true. Here's an example of a linear inequality problem and its solutions. Example: solve the inequality 3x 2y greater than 6. Solution: the solution to the inequality 3x 2y greater than 6 is the region above or on the boundary line of the equations 3x 2y equals 6. Here's another example of a linear inequality problem and its solution. Example: solve the inequality 4x plus 5y less than 20. Solution: the solution to the inequality 4x plus 5y less than 20 is the region below the boundary line of the equations 4x plus y equals 20.
Hi, I'm Jana Maydida Kanay and will be reporting about modeling with linear programming. Linear programming, LP, or linear optimization, may be defined as the problem of maximizing or minimizing a linear function that is subject to linear constraint. The constraint may be inequalities or equalities. The optimization problems involve the calculation of probit and loss. Linear programming problems are an important class of optimization problems that helps to find the feasible region and optimize the solution in order to have the highest or lowest value of the function. In other words, linear programming is used to depict or predict complicated real-world relationships by using a linear function. A linear programming problem can be described completely by a linear equation, consists of decision variables, which are unknown to determine by the solution to the model, constraints to represent the physical limitation of the system, and an object function. Linear programming by graphical method. If there are two decision variables in a linear programming problem, then the graphical method can be used to solve such a problem easily. Suppose we have to maximize z equals 2x plus 5y. The constraints are x plus 4y less than or equal 24, 3x plus y less than or equal 21, and x plus y less than or equal 9, where x greater than 0 and y greater than 0. To solve this problem using the graphical method, the steps are as follows. Step 1. Write all inequality constraints in the form of equations. X plus 4y equals 24, 3x minus y equals 21, x plus y is equal to 9. Step 2. Plot these lines on a graph by identifying test points. Step 3. Identify the feasible region. The feasible region can be defined as the area that is bounded by a set of coordinates that can satisfy some particular system of inequalities. Step 4. Determine the coordinates of the corner points. The corner points are the vertices of feasible region. O is equal to 0 and 0, A is equal to 7 and 0, B is equal to 6 and 3, C is equal to 4 and 5, D is equal to 0 and 6. Step 5. Substitute each corner point in the objective function. The point that gives the greatest maximizing or smallest minimizing value of the objective function will be the optimal point. Corner points. O is equal to 0 and 0, A is equal to 7 and 0, B is equal to 6 and 3, C is equal to 4 and 5, D is equal to 0 and 6. While Z equals 2x plus 5y is 0, 14, 27, 33, 30. 33 is the maximum value of z and it occurs at c, thus the solution is x equal 4 and y is equal to 5. Always remember, step 1 is to identify the decision variable, step 2 is to formulate the objective function, check whether the function needs to be minimized or maximized. Step 3, write down the constraints. Step 4, ensure that the decision variables are greater than or equal to 0, non-negative restraint. Step 5, solve the linear programming problem using either the simplex or graphical method. In solving the linear programming method using the graphical method, we use this or identify the decision variable, formulate the objective function, the constraints, and the variables that are greater than or equal to 0. The difference between graphical and simplex method. Graphical methods can be used only when two variables are in model. Simplex can handle any dimension. Graphical method must evaluate all corner points if the corner point method is used. Simplex checks lesser number of corners.
Hello, I'm the last reporter of this group. I am Noreen Joy C. Corpus from BSA 1C. So, we will tackle about simplex method. Simplex method can solve 2 to 3 or more variables that are involved in a linear programming problem. Kasi sa isang graph, there are just two variables, which is x and y. So, through simplex method, we can solve more than two variables. Simplex method is developed by George B. Danzig in 1947 while on assignment with the U.S. Air Force. The simple method is a repetitive optimizing technique kasi there are procedures or rules na kailangan mong sundin but the process is paulit-ulit lang hanggang makuha yung sagot. So, just as I said, it repeats the process, mathematically moving from one extreme point to another extreme point in the graphical method until an optimal solution is obtained. Next, there are imposing requirements on the LP or linear programming constraints. Example of constraints are 10x sub 1 plus 10x sub 2 plus 20x sub 3 less than or equal to 100. That are the example of constraints. So, there are requirements in constraints. First, all the constraints are equations with non-negative right-hand side or RHS. Second, all the variables are non-negative. Then, converting inequalities into equation with non-negative right-hand side means the RHS represents the availability of resources, while left-hand side represents the availability of resources by all the model activities or variables. The excess amount of right-hand side over the left-hand side then yields to unused amount of the resources. Ano nga ba yung unused? Dahil sa ating right-hand side, pwedeng magkaroon ng unused doon sa ating left-hand side. Which is, yung mga ating unused is, ito yung ating slack variable. Kung saan yung slack variable natin is yung pupuno para mag-equal yung ating left-hand side at right-hand side. Parang ganito siya. So, 5x sub 1 plus 10x sub 2 is equals to 50. Para makompensate natin or mag-equal tayo dito sa 50, ang bubuo doon o pupuno is yung ating slack variable para mag-equal tayo sa ating right-hand side. So, ang slack variable natin is S1. So, ito yung pupuno dun sa left-hand side para nga maging equal siya sa 50. Yun. Then, we're now going to solve a problem. Gina is the production manager of a clear shampoo and she wants to determine the production mix that will result in maximum profit. She is able to determine the data necessary for her to make a decision. It will take 5 minutes to mix 1 case of men's shampoo and 10 minutes to mix 1 case of women's shampoo. And she has a total of 100 minutes available for the mixing process per day. It will take 7 minutes to bottle the 1 case of men's shampoo and 7 minutes to bottle 1 case of women's shampoo. And she has a total of 84 minutes available for the bottling process per day. It will take 9 minutes to pack 1 case of men's shampoo and 5 minutes to pack 1 case of women's shampoo, and she has a total of 90 minutes available for the packing process per day. She will earn 6 for every case of men's shampoo produced and 8 for every case of women's shampoo produced. And now that we are finished in reading our problem, now we're going to know our objective function and subjective to or constraint. Objective function is max z is equals to 6x sub 1 plus 8x sub 2, while subject to or constraints is 5x sub 1 plus 10x sub 2 is less than or equal to 100. So, for mixing yon. Then, 7x sub 1 plus 7x sub 2 is less than or equal to 84. For bottling naman yon. Then, 9x sub 1 plus 10x sub 2 ay 5x sub 2 pala is less than or equal to 90 for packing. Then, x sub 1 and x sub 2 is greater than or equal to 0. So, nakuha natin tong mga given na to sa ating given problem. So, next, convert inequality equation or constraints into equality and set up variables. So, magkakaroon tayo ng x sub 1 for men's shampoo, x sub 2 for women's shampoo, and yung ating panibagong variable which is yung S1 or ating slack 1 or unused minutes of constraints 1, and S2 for constraints 2, and S3 for constraint 3. Then, set up the objective function where 0 is the assigned profit per unit of a slack variable. Kung saan yung ating objective function ay magkakaroon tayo ng 0S1 plus 0S2 plus 0S3. So, i-convert natin yung ating constraints into equality with slack, kung saan, tulad na sinabi ko kanina, yung ating constraints or ating equation is magkakaroon tayo ng slack or unused natin para ma-compensate or mabuo o mag-equal. Siya yung bubuo doon sa ating right-hand side. So, mapapansin nyo, nakared yung may 0S1, 0S2, etc. Kasi, hindi naman siya kailangan talagang ilagay kasi wala naman siyang value. So, yung S1, S2, and S3 is dedicated lang sa kung saan sila nakalagay. Kung si S1 ay nakalagay sa constraints 1, then nakalagay naman sila S2 and S3 sa constraint 2 and 3. And yung ating X sub 1, X sub 2, S1, S2, S3 is greater than or equal to 0. Then next, we write the objective equation as max z is equals to 6x sub 1 plus 8x sub 2. So, ililipat lang natin sila sa kabila kung saan z minus 6x sub 1 minus 8x sub 2 is equals to 0. So, next, magka-create na tayo ng tableau. Ito na yung mga ating nare-write is objective function and yung ating constraint. Kung saan, gagawa tayo ng table. So, sa table, meron tayong basic variable, column, and yung ating mga respective variables natin na x sub 1, x sub 2, s1, s2, s3, and RHS. And ililipat lang natin yung mga value dito sa ating table. Kung saan sa Z, ang nakapaloob dito is yung negative 6, negative 8, 0, 0, 0, and 0. For S1 naman, 5, 10, 1, 0, 0, and 100. For S2, 7, 7, 0, 1, 0, 84. For S3, 9, 5, 0, 0, 1, 90. So, after natin malipat yung mga value, then susunod na yung next step, which is the Gauss-Jordan operation. Gauss-Jordan operation, it identifies the entering variable column and the leaving variable. Pivot column means entering variable. Pivot row means leaving variable. Then pivot element is the intersection of pivot column and pivot row. So, paano ba malalaman kung ano yung pipiliin natin na pivot column at pivot row variable? Then pivot element is the intersection of pivot column and pivot row. So, paano ba malalaman kung ano yung pipiliin natin na pivot column at pivot row? So, by using simplex optimality condition, which ito yung procedure natin kung paano tayo pipili ng entering value or pivot column. So, yung most negative coefficient nung ating objective equation, which is the Z. So, sa objective equation lang tayo titingin. Sabi, most negative coefficient. So, ang ating most negative coefficient is yung negative 8. So, yung pivot column natin is yung column ng x sub 2 kasi nandun yung negative 8. So, next naman is yung leaving value. Is compute natin or kukunin natin yung ratio ng right-hand side natin dun sa napili nating pivot column or yung ating entering value. So, ang ating requirement dyan is minimum positive ratio. Then, paano ba siya i-solve? So, right-hand side divided by pivot column. So, let's solve. So, first is 100 divided by 10 is equals to 10. So, yun yung ratio. Then, next, 84 divided by 7 is equals to 12. Then, the last is 90 divided by 5 is equals to 18. So, ang sabi, para mahanap yung pivot row is yung minimum positive ratio. So, ang minimum positive ratio natin is positive 12. Therefore, ito yung pivot row natin or ang leaving value natin. After natin malaman yung ating pivot column and pivot row, so yung intersection ng pivot column and pivot row is yung ating pivot element, which is yung ating pivot element is 10. Then, for pivot row, replace the leaving variable in the basic column with the entering variable. So, yung S1 is yung ating leaving variable and x sub 2 is yung entering variable. May formula tayo for new pivot row. New pivot row is equals to current pivot row divided by pivot element. So, dito na natin magagamit yung pivot element. So, kailangan natin talagang malaman yung pivot element. So, now, magkakreate na tayo ng new pivot row. So, sa table, papalitan natin yung leaving variable which is yung S1 ng entering variable which is yung X2. Then, gagamitan na natin yung ating formula na sinabi ko which is new pivot row is equals to current pivot row divided by pivot element which is ang current natin is yung S1 is equals to 5, 10, 11, 0, 0, 100. Then, yung pivot element naman natin is 10. So, pwede na tayo mag-solve. So, first is 5 divided by 10 is equals to 1 half. 10 divided by 10 is equals to 1. 1 over 10 is equals to 1 over 10. 0 over 10 is equals to 0. Then again, 0 over 10 is equals to 0. 100 over 10 is equals to 10. So, ang sagot is pwedeng fraction or decimal. Pero, ang gagamitin natin is fraction. Pero, nasa sa inyo naman kung ang gusto nyong sagot is decimal or fraction. So, meron na tayong new pivot row which is yung 1 half, 1, 1 over 10, 0, 0, and 10. So, next naman natin is magkakreate na tayo ng new pivot column ng Z, X2, and X3. So, paano po yun? So, meron tayong formula dyan. New row is equals to current row minus pivot column coefficient times new pivot row. So, let's answer Z muna. So, ang current row nito is yung nasa Z row which is negative 6, negative 8, 0, 0, 0, 0. Then, yung pivot column coefficient is so, kung ano yung column, so for this 0, ang pivot column coefficient natin is negative 8. Kung sa S2 naman, ang magiging pivot column coefficient naman natin is 7. Then, new pivot row is yung 1 half, 1, 1 over 10, 0, 0, 10. So, kung nasa column ka ng X sub 1, ang new pivot column mo is yung 1 half. Kung nasa X sub 2 ka naman, ang new pivot column mo is 1. So, kung ano ang katapat ng current row mo, yun din ang new pivot row nyo. Gets ba? So, now, let's solve for Z. So, ang formula is, ulitin ko lang, new row is equals to current row minus pivot column coefficient times new pivot row. So, first, negative 6 minus negative 8 times 1 half is equals to negative 2. Pangalawa, negative 8 minus negative 8 times 1 is equals to 0. So, tip lang dito. Sa lahat ng isi-solve mo sa may pivot column, which is yung sa X2, yung negative 8, 1, 7, 6. Lahat yan kapag sinolve mo, always 0 ang sagot. So, yun lang. Next, 0 minus 8 times 1 over 10 is equals to 4 over 5. 0 minus negative 8 times 0 is equals to 0. 0 minus negative 8 times 0 is 0. 0 minus negative 8 times 10 is equals 280. So, yun lang lahat naman ang solve natin sa Z. Ngayon, diretso na tayo sa S2. So, same lang din naman kagaya sa procedures natin sa Z. Na hanapin muna natin yung current row, pivot column coefficient, and yung new pivot row. So, sa current row, ito yung 7, 7, 0, 1, 0, 84. Then, yung pivot column coefficient is yung 7. Then, sa new pivot row naman, kagaya lang din siya sa Z, which is yung 1 half, 1, 1 over 10, 0, 0, 10. So, ganun pa rin naman yung formula. Yung new row is equals to current row minus pivot column coefficient times new pivot row. So, let's start. So, 7 minus 7 times 1 over 2 is equals to 7 over 2. So, sumunod is automatic ang sagot dyan is 0. Kasi nga, sabi ko nga sa inyo, lahat ng nasa pivot column, kapag sinolve nyo yan, ang magiging sagot always is 0. So, next na, 0 minus 7 times 1 over 10 is equals to negative 7 over 10. 1 minus 7 times 0 is equals to 1. 0 minus 7 times 0 is equals to 7. 84 minus 7 times 10 is equals to 14. So, tapos na naman tayo sa S2. Then next, for our S3. Ganun ulit. Same procedures lang naman ang ginagawa natin. So, hanapin ulit yung current row, pivot column coefficient, then yung new pivot row. So, sa current row ng S3 is yung 9, 5, 0, 0, 1, 90. Then, ang pivot column coefficient niya is 5. Then, ang new pivot row, ganun pa rin, wala namang pinagbago, is yung 1 half, 1, 1 half, 1, 1 over 10, 0, 0, 10. Ulitin lang yung formula. Ganun lang din sa Z tsaka sa S2. So, let's start na sumagot. So, 9 minus 5 times 1 over 2 is equals to 13 over 2. Then, sa second is 0. Then, next is 0 minus 5 times 1 over 10 is equals to negative 1 half. Then, 0 minus 5 times 0 is equals to 0. 1 minus 5 times 0 is equals to 1. 90 minus 5 times 10 is equals to 40. So, natapos na natin lahat sagutan yung nasa table ay babalik tayo ulit sa umpisa para matanggal yung negative sa objective function and para makuha na natin yung sagot. So, hanapin ulit natin yung pivot column, pivot row, and pivot element. So, paano ba ulit nakukuha yung pivot column? Ito yung most negative coefficient sa objective function or yung Z. So, kapag titingnan natin yung sa Z, doon lang tayo tututok ha. So, kapag titingnan natin yon, ang nandun na lang na may negative is yung negative 2. So, ito yung ating pivot column. Then, ang pivot row naman natin is, para makuha is, right hand side divided by yung pivot column na napili natin, which is yung x sub 1. So, 10 divided by 1 over 2 is 20. The next is 14 divided by 7 over 2 is 4. Then, 40 divided by 13 over 2 is 80 over 13. So, ang So, ang requirement doon is yung minimum positive ratio or yung pinakamababa. So, ang pivot row natin is yung S2, which is ang ratio niya is 4. So, next naman is yung pivot element. Para makuha siya is the intersection ng pivot column and pivot row. So, ang intersection nito is yung 7/2. So, after natin malaman yung entering and leaving variable natin, we'll make the new pivot row. So, para makuha yung new pivot row natin, may formula nga tayo sinabi doon. Diba? So, new pivot row is equals to current pivot row divided by pivot element. So, kagaya lang talaga ng procedures kaninang ginawa natin. So, tatanggalin na natin yung leaving variable which is yung S2. Then, papalitan ng entering variable, which is yung x sub 1. So, then, sasagutan na natin. So, 7/2 divided by 7/2 is equals to 1. 0 divided by 7/2 is equals to 0. 7/10 divided by 7/2 is equals to negative 1/5. 1 divided by 7/2 is equals to 2/7. 0 divided by 7/2 is equals to 0. 14 divided by 7/2 is equals to 4. So, tapos na tayong mag-ano ng ating new pivot row. So, next is, kukunin na ulit natin yung new pivot row ng Z, X2, and S3. So, let's start with Z. Aalahanin muna natin yung formula para makasagot sa new pivot row. So, ang formula is new row is equals to current row minus pivot column coefficient times new pivot row. So, hanapin natin yung current row, pivot column coefficient, and yung new pivot row. So, ang current row ng Z is yung row niya lang din. Yung negative 2, 0, 4/5, 0, 0, and 80. Then, ang pivot column coefficient niya is negative 2. Then, ang new pivot row niya is yung 1, 0, negative, 1/5, 2/7, 0, and 4. So, let's start. So, sa first, ang sabi ko nga sa inyo, 0 ang sagot doon kasi lahat ng isosolve mo sa pivot column, ang always magiging sagot dyan is 0. So, next, 0 minus negative 2 times 0 is equals to 0. 4/5 minus negative 2 times negative 1/5 is equals to 2/5. 0 minus negative 2 times 2/7 is equals to 4/7. 0 minus negative 2 times 0 is equals to 0. 80 minus negative 2 times 4 is equals to 88. So, tapos na tayong kunin lahat ng new pivot row ng Z. Then, next is yung x sub 2. So, ganun ulit. Ganun, paulit-ulit lang yung procedures. So, hanapin ulit natin yung current row, pivot column coefficient, and yung new pivot row. So, ang current row is yung row lang nung x sub 2, which is yung 1/2, 1, 1/10, 0, 0, 10. Then, yung pivot column coefficient niya is 1/2. Then, ang new pivot row niya is 1, 0, negative 1/5, 2/7, 0, and 4. So, ang first is 0 automatic kasi nga lahat ng nasa pivot column, kapag isolve mo, 0 ang always na sagot. The next is 1 minus 1 over 2 times 0 is equals to 1. 1 over 10 minus negative 1 over 2 times negative 1 over 5 is equals to 1 over 5. Next, 0 minus negative 1 over 2 times 2 over 7 is equals to negative 1 over 7. 0 minus negative 1 over 2 times 0 is equals to 0. 10 minus negative 1 over 2 times 4 is equals to 8. So, please try to compute also so that you can understand it better. Kasi baka meron sa inyo hindi nakakasunod. So, kapag ganon, please just ask me para matulungan ko kayo. So, let's continue. So, nasa S3 na tayo. Kagaya lang ng always na ginagawa natin, hanapin natin yung current row, pivot column coefficient, and yung new pivot row. So, ang current row natin is yung row lang ni S3, which is yung 13 over 2, 0, negative 1 over 2, 0, 1, 40. Then, ang pivot column coefficient niya is yung 13 over 2. Then, ang new pivot row niya is yung 1, 0, negative 1 over 5, 2 over 7, 0, 4. So, let's start. So, first, automatic 0. Then, next is 0 minus 13 over 2 times 0 is equals to 0. Negative 1 over 2 minus 13 over 2 times negative 1 over 5 is equals to 4 over 5. 0 minus 13 over 2 times 2 over 7 is equals to negative 13 over 7. 1 minus 13 over 2 times 0 is equals to 1. 40 minus 13 over 2 times 4 is equals to 14. So, next, ganun ulit, babalik ulit tayo sa umpisa. Aalamin natin yung pivot column or yung pagpili ng most negative coefficient. Pero, this time, wala na pong negative sa ating Z or yung objective coefficient. So, meaning, pag wala ng negative, stop na tayo. Yun na yung time para huminto na tayo sa paggawa ng tableau. So, then, kukunin na natin yung right-hand side value ng ating Z, X sub 2, X sub 1, and slack 3. So, sa Z, meron tayong 88. Sa X sub 2 naman, meron tayong 8. And sa X sub 1 naman, meron tayong 4. And sa slack 3, meron tayong 14. So, let's check kung tama ang ating ginawa. So, yung 5x1 plus 10x sub 2 is less than or equal to 100, mixing, and etc. Ayun yung mga constraints natin na nakuha natin dun sa problem. So, iaano lang natin yung mga nakuha nating right-hand side value dun sa Z, X2, X sub 2, X sub 1, and S3 dun sa constraint natin. So, 5 times 4 plus 10 times 8 is equals to 100. So, tama naman tayo kasi equal nga siya sa 100 sa mixing. Then, next is 7 times 4 plus 7 times 8 is equals to 84. Then, tama naman, equal siya dun sa battling din. Then, 9 times 4 plus 5 times 8 is equals to 90. So, hindi siya equal. So, So, 9 times 4 kasi is 36. Tapos, 5 times 8 is 40. So, kapag pinag-plus mo yon 36 plus 40, 76 lang. So, dun papasok yung 14, which is yung slack natin. So, therefore, ito yung unused minutes natin na kung saan siya yung pupuno sa ating constraint or sa left-hand side natin para mag-equal siya sa right-hand side. So, 76 plus 14 is equals to 90. So, equal na siya dun sa packing. So, sa conclusion, Gina should produce 4 cases of men's shampoo per day and 8 women's shampoo